Hello guys, nice to see you. Do you hear me?
Yes.
Hello.
Good. Let's wait maybe a couple of minutes and then we will start.
Sorry, may I ask,
Yes, sure.
is it going to be a real lecture or just an introduction?
We will start from introduction, of course, but hopefully we will manage to start covering already some material by the end of this lecture. And we'll see how it goes, but I believe that most of you already are familiar with these online teaching rules for general physics, which we together experienced during first semester. So everything is pretty much the same. So we will just highlight this. And if there are any questions, we will consider them and then proceed to actual material. Okay. I believe who wanted to join us already here. It's actually not so many people, 59 about. I guess some people will join. Yeah, hello everyone who just joined to us. And I'm first of all would like to welcome you on Physics 162. Hope you had nice holiday season and recovered and regenerate yourself after this not easy fall semester in last year. Unfortunately, we need to continue our online teaching activity since the situation with the quarantine restrictions is quite difficult. And this semester we will still work online. But it doesn't mean that it will affect our quality of studying and experience, and we will do everything possible to make it as efficient as we can. So let's start from those links which I sent you on Moodle and also to your emails. I hope all of you got them. So there is a link to a Google folder where are 3 documents, like syllabus, a manual for labs for this semester, and manual for the course in general for lectures. So this document manual for the course is very important, and please read it carefully. So because it provides you with pretty much all necessary information. As I mentioned, we will have online lectures. There will be 3 lectures per week, Monday, Wednesday, and Friday. You are welcome to come up with questions which are related to the physics concepts and theories. That is the main topic which we're going to discuss. So definitely there will be some examples of some particular problems, but it's not our goal during lectures to practice solving problems. Problems you will practice solving problems you will practice during recitations. And here the main goal is to teach you the concepts of physics, and in particular our topics for this semesters will be electricity, electromagnetic dynamics, and light and optics. So it will be electricity, magnetism, and optics. It's quite a lot of material, and definitely it will be necessary to be actively involved in the studying process for you from the early beginning. So don't leave it for some long time and put it in a long drawer, because we will cover quite many topics within just one semester, which might be kind of challenging for some of you, but the best advice I can give you, just start working consistently from the start of the semester. So as you have seen in the manual, I hope you read it. If not, please do it. And you will not find many changes. It's quite similar to the previous manual you received at the beginning of the previous semester. So the evaluation of your work will be split in different categories. And you will have 10 laboratory works, like assignments, which will weight 20% of the final grade. Then will be 12 weekly homework assignments, so you will get it every week. Started from first week you will not get, as I remember. Then second week it will be some training assignment, and starting from the third week you will get homework assignments which are going to be evaluated, and we will drop the lowest grade for these homework assignments. Then we will have 3 midterms. Each in total, these 3 midterms will weigh 24%, and also the lowest grade for the midterm will be dropped, so it will not affect your final grade. Yeah, so there is a question regarding dropping the course if you feel that you had already this course. So this course is for a very broad spectrum of students, and there is different majors. Some of you may think that it is already has been covered previously in some of your courses, but some of you will definitely learn a lot during this course. So this is the course for general, quite wide audience of students. And in terms of skipping this, most likely it's not possible. You need to pass. It's a core course. With this question, you may contact some vice dean for academic affairs, but just can double check. However, I doubt in that, because this is a core course and mandatory for everyone to pass. How many problems will be in homework assignment? So far, I'm not sure, but it will be comparable to those numbers which you were receiving during the first semester. So there will be not much of a difference. And after 3 midterm exams, of course, you will have final exam, which will cover all topics of this semester of this course, and this will be 14% of the final grade. So regarding attending lectures, so we cannot punish you for not attending online lectures. That's why it's not mandatory. However, from the previous experience, word mandatory somehow by many of you is understood like it's mandatory not to come to lectures. Unfortunately, very limited number of students were consistently attending online lectures, and that is of course not appropriate. So because of any technical or personal reasons, it's quite natural to expect that you will miss certain lectures and you will not attend all of them. But if majority of students do not attend all lectures of the course and attend probably the first and the last lecture, that is not appropriate approach. And I believe that you will consider this seriously and respectfully. So that's why please, based on your conditions, try to do your best to attend as regularly as possible online lectures, because even if you believe that you know everything, it will be not bad to refresh some aspects. And another thing that during lectures we also have some discussions of like either students' concerns or I deliver you some current information which is relevant ongoing during the course. And it will be much easier if majority of you receive it immediately during the lecture. The tolerance of answering long up is the same. Yeah, it will be the same, it's 2%, but keep in mind that this 2% it's plus and minus 1%. So it's in the range around 0. So it's either 1% larger or 1% smaller. It's not plus or minus 2% of the value. So this is like in this 2% is kind of an absolute value of percents, which are allowed in terms of deviation from the accurate answer. Okay, so other from that, I do not see any differences between our working conditions during previous semester. Of course, you need to be very careful with long kappa. Keep in mind that all these answers should be in appropriate format. This is important. We mentioned like millions times during the first semester that this is the current working conditions which are necessary for us, and we have to accept them, and we need to follow these rules. So answers should be accurate without any technical errors, because I understand your feelings that sometimes you solve problem correctly, and let's say most trivial example could be just put comma instead of dot, and then feel not fair with respect to your contribution to give you 0 point for this problem. Yeah, I understand your feelings, but these are conditions we are working and accepting for this course. So unfortunately, we cannot do anything better. So that's why please be very careful with that. We have this Azamat Orazbayev. He is the long kappa administrator for this semester also. If you have any technical issues or questions regarding long kappa, please contact him. His email is in the manual. Also, regarding laboratory works, so if someone doesn't know, I am currently responsible, I mean, it's my responsibility to be the laboratory administrator. So, and part of my responsibility in this aspect is to help LAs and students to find the compromise between each other in terms of any issues when they, for instance, students are not agreed with the grade received from LA. So there is manual for labs, and there is a form which should be filled when you like appeal form if you believe that your grade is not fair. But please be very serious about this and try first to have a detailed discussion with LA before you contact, you write this appeal, because experience shows that most cases actually could be resolved at the level between interaction between student and LAs. So please contact your LAs if you have any questions regarding certain grades. Also keep in mind that plagiarism is not accepted in any form, and you will be working in groups. So there will be something like 3 people in a group, and a group of students will report the each laboratory work, and this report, this grade will be shared between all group members. And that's why please keep an eye on each other and try to be sure that you are working with responsible people who do their work properly, because there were some cases previously that one of the group members just copied paste part of the report without noticing other students, and then of course plagiarism software have shown this issue, and we didn't have any choice but only to punish all group together, because it is quite clearly specified that all group members are responsible for the and share the final the grade for each laboratory report. That's why be very careful with this and try to avoid these unpleasant situations. So, any questions right now regarding the manual? Who hasn't have read this manual, please do this in the due course and read it carefully so you make it clear for you. It will be easier from the early beginning to start working properly, and you will have a better chance to get higher results starting from the early beginning. Oh yeah, I think you have this. You should have meetings with your LAs, so there will be some designated time in your schedule for laboratory work. And definitely they will discuss in more details all these rules regarding laboratory work. So that will be explained you in details again. That is pretty much everything what I wanted to tell about this course. Also, the same will be as last semester, all our online lectures, in order to provide some asynchronous experience, studying experience for you. We will record them, and all these online lectures will be available online. So previously I was uploading them to Moodle. We'll see if I'm going to do it now the same way, but we also check in that Google folder, like with this link I shared with you. There is a folder with recorded like lectures, I believe, and we will upload these video files there. I believe all instructors will do that. If not, then at least I can tell that for sure I will upload my recorded lectures there. So you can access them anytime. So if because of any reasons you didn't have a chance to attend the lecture, it would be strongly recommended to watch the video file and catch up with the current material which we are working with. And again, please do your best to attend lectures as often and as regularly as possible. This is actually your responsibility as a student. So, okay, so during lectures, initially we had a plan to make it like flipped course, and since we provide all textbooks and video lectures, links, so we expected that students would have a chance to work with the material and ask some specific questions they are not familiar with and do not understand from the textbook. However, this approach seems to me not very efficient. That's why, as I did last semester, I was trying to give lectures online. So actually we were discussing the most important topics and concepts, deriving most common and important equations during the online lectures. And that's why I believe that it will be very useful addition to the textbook or your previous knowledge in electricity, magnetism, and optics. That's why please find your time and organize your work in that way that you can attend lectures. And sure, on the way, we will discuss any questions from students. Depends on the students' interest or some concerns regarding the current topic. So you are welcome to ask your questions, and we will discuss it. So again, it will be much beneficial, more beneficial for many students if there are many students attending the lecture, because once we discuss certain question from one student, there is a great chance that there are similar concerns or questions from other students who just didn't ask this, but this discussion would be beneficial for everyone. So don't miss such opportunities and take maximum what you can from this course. Yeah, so far, as you may see, we have 31 participants, and this is the first lecture. Best to my knowledge, that should be about 110 students. However, we already are missing quite a lot. And if you have a chance, if you have some contacts, and I believe you do, with each other and your classmates, please let them know that they are strongly encouraged to attend lectures. Okay, if you have any questions further, let me know. And now I think that we can start discussing our first topic with electrostatics. And electrostatics is a field of study which deals with interaction with electric field and also interaction between different stationary charges within some inertial system of coordinate. And quite obviously, we need to define what is electric charge, since it's a new concept with respect to all materials which we work with during the first semester. So electric charge is some quantity which describes the feature of bodies to interact electrically with each other based on, and this quantity describes the forces of this interaction and energy of this interaction. So this is a fundamental feature of matter. So charges exist, electrical charges exist everywhere. So it's like building blocks of the matter which is around us. And nevertheless, we have like neutral atoms under normal conditions when they are not excited. These atoms consist of negatively charged electrons and positively charged with whiteboard. We will definitely work with whiteboard. Now I just some general discussion. We will come to that point. And also there are positive charges in the nuclear. So nucleus consists of neutral neutrons and positively charged protons. And these charges, they just these objects, electrons and elementary particles, electrons and protons, they possess charges as their fundamental feature. So these charges do not come and disappear from anywhere. So we have matter. Matter consists of molecules, atoms. There are electrons and protons, and under normal conditions, usually some macro bodies are also neutral. However, by instance, by friction between two different materials, which have different physical properties, it is possible to redistribute these charges. Redistribute these charges. And now let's try to okay. Can you guys please switch off your microphone? Just don't make noise when you don't want to ask any questions. So this guy, Franklin Roosevelt, Benjamin Franklin, he is quite known. Everyone has seen this guy, but not everyone knows that he was actually a scientist. And he figured out that there are two types of electric charges. And the way the how humankind knew for a long time how to charge bodies, it can be done by friction of two different materials. Let's say if we have some glass stick and some silk, by having some friction between this material, negative charges are accumulated on the silk and positive on the glass. So if we change materials, depends on their surface properties, this can be opposite. And by doing quite simple experiments, which can be shown here, by the way, do you see my screen now?
Yes.
Yes.
We see.
So, you can see that if we have different signs of electrical charges, they are attracting. And if we have the same signs of electrical charges, they are repelling from each other. So there is some force, there is some interaction between these charges. And but at that time, it was not clear what is the nature of these charges and where exactly they are coming from and what is the carrier of these electric charges. However, with going further in terms of understanding the matter and role of electricity, it was possible to distinguish between all type of materials. We could consider them from divide them in two types. One is insulator, another is conductor. So in case of a conductor, the classical example of a conductor is any metal. And in this case, electrons can move freely in the material. In the case of insulator, charges cannot move. They are quite strongly bound and only can be slightly rearranged with respect to their equilibrium position. So here it would be nice to show two options for electrifying bodies by induction. So when we don't have any physical contact. So previously we were considering, okay, when we have physical contact between two different materials, there is some friction, and because of that, there is charge transfer. However, it's possible to charge bodies without having a direct physical contact. And for this purpose, it's nice to consider an example of some metal conductor sphere where we have equal number of negative and positive charges. And these negative charges are electrons. Positive charges are like some ions which are in the crystalline lattice, so they cannot move. And once we put close to this spherical, this metal sphere, some negatively charged body, see from the left side, because of repelling between negatively charged body and mobile electrons, they are pushed to the right side of the sphere. So we create some space charge in the inside the conductive sphere. And if this conductive sphere is grounded at some point, so grounded means it's connected with another conductor, which is some wire, to the ground, to the planet Earth, is considered to be like a huge source of charges which can accept and provide charges without a noticeable change of its surface potential. And this is very important because ground could be always considered as the same potential can set it to 0, and that's very useful concept in electricity. So if we connect under these conditions this sphere to a ground, because of excessive potential, we have accumulated, not compensated mobile charges at the right side. Part of these charges will just go to the ground in order to equilibrate potentials between two bodies, the sphere and the ground. Once we got rid of certain number of these electrons, this wire can be eliminated, and then we will end up with, again, isolated metal sphere. But in this case, there will be much less electrons and positive charges. And if we take, but they will be still accumulated in this right side because they will be repelled from this negatively charged body. And if we take off these negatively charged bodies, the remaining negatively charged electrons will be distributed randomly, like uniformly all over the sphere, but the total net charge will be positive of this sphere because we will have more positive charges than negative charges. And net charge will be positive, so this body will be electrically charged. However, as you may see from this sequence, we didn't have any physical contact between the bodies. So that means that it's possible to charge bodies even without having direct contact between them. So another example is relevant for dielectrics. And the question is, why, if we have some charged body, let's say this stick, which you see here on this image, why neutral, electrically not charged pieces of paper are attracted by this stick? Do you have any ideas? We would expect that if it's negatively charged, charge is 0, then there should not be any interaction with other charges because initial charge of these pieces of paper is 0. We didn't charge it, but it still interacts. So the answer to this question can be seen here, and it comes from the feature of dielectrics. As I mentioned before, as opposite to conductors, which this metal, oops, what is going on here? As opposite to, who is drawing on my screen? Interesting. If you have something to say, you're welcome. About dielectrics now. So if we cannot move charges from, what's going on? Arman, who is doing this? Okay, guys, please don't play and listen. So when we have arrangement, when we have some electrically charged, let's say positively charged body, which is approaching the surface of dielectric, charges in dielectric, like positive charges, they also repelled from the positively charged body. However, in this under these conditions in the dielectric material, they cannot move in the volume of the material, and the only thing what can happen is so-called polarization. So they rearrange in that way that positive charges are oriented from the surface and negative charges are accumulated next to the surface because they are attracted by positive charges of this body which is approaching the dielectric. Because of this, we have some net negative charge accumulated at the surface of the dielectric, and this is the reason why we have, because of this polarization effect, we have interaction between charged bodies and initially neutral, electrically neutral dielectric materials. In this example, pieces of paper. So from this picture, and that you can do easily, this experiment with anywhere, and you can just use pieces of paper and charge any plastic pencil or pen by having some friction to some silk or wood. You see that electrostatic interaction is so electric forces are much stronger than the gravitational forces, because this, regardless of gravitational force which pulls this dielectric materials like pieces of paper downwards, electrical interaction because of the polarization effect in the electrics easily outperforms the gravity interaction, and that's why we can make a conclusion that electrical interaction is much, like orders of magnitude, stronger than gravitational interaction. So this should be taken into account when you consider certain cases in terms of solving problems or considering some examples when it's necessary to take into account electric and gravitational interaction. Quite often, gravitational interaction is just neglected. Okay, so now let us stop this sharing. Yes. And now let us change the camera so I can start writing. Okay, what is this? That's not good. Take some. Why it just was working recently? Okay, let's change it here. That is strange. Yeah, unfortunately, at this time, My tablet somehow doesn't want to connect properly. I need to figure out what's the reason for that. So we are in any way approaching the end of this lecture, scheduled up to 3:50. So we had short introduction and specifying what are very general, in general terms, what are electric charges, what types of electric charges exist. And our next discussion will be about Coulomb's law. So we will introduce Coulomb's law and consider a number of cases, like some examples of application Coulomb's law. Afterwards, we'll proceed further. So on Wednesday at 3 p.m., we will be working again. So please don't forget and try your best to attend lectures. If you have any questions, you're welcome.
Yes, I have one question, Prof.
Yeah, sure.
Before the lecture on Wednesday, should we do something? Should we prepare somehow?
What do you mean prepare?
I don't know. Maybe I missed something.
No, you didn't miss anything. So we will. So far, you don't have any assignment first week, and you will have assigned like homework assignment starting from the second week. It will be test homework assignment. You will not get any grades for that. And starting from the third week, there will be homework assignment with regularly each week with certain number of problems which have to be solved. Yeah, other from that, you just need to read the textbook, learn the so regarding chapters and plans for working with the textbook in the manual, there are there's like a table and there's very detailed information which topics, which chapters of the textbook should be considered and what you need to read in order to follow up the progress of the course. If you have specific questions on the physics concepts and theories, you're welcome to ask them during lectures. And this is the format we are going to work. Just need to fix this issue with the tablet where it will be possible to derive equations and proceed further with quite normal structure of a lecture.
Okay, thanks. I have another question. Is
Yeah,
there
sure.
any list of constants for long kappa questions? Like what value we should pick to calculate?
Yeah, so I believe with this question, please email the long kappa administrator. That's a person who knows the most about long kappa. So it's quite new platform for all of us. And this is the person to ask for sure this type of questions. But they should not be, of course, very different from commonly accepted constants, value, like accuracy of constants provided. But to double check this, yeah, please contact our long kappa administrator. Okay, guys, then was nice to see you all and start the second semester. So looking forward to see you all, and also maybe your friends who didn't have a chance to attend this lecture on our lecture on Wednesday. Take care and have a good evening. Bye-bye.
Thanks, bye.
Bye.